we know these formulas so far? We started out at the beginning of the term with our good old stress equation, stress equals force over area, PSI. Then we went on to strain, deformation over length, and just now we went on to modulus of elasticity, stress over strain, stress over strain. So we've got these formulas with various kinds of terms, and we could use all these. These are like tools in our toolbox to figure stuff out. So let's see about that. Here's an example. We have a 10,000 pound weight, and it's hanging from this 24-inch bar. It's got an area of 1 square inch. Whatever size it is, it's 1 square inch of area. And the modulus of elasticity of this steel is 30 million psi. Sometimes you see people round up to 30 million. Question is, how much will the bar stretch? So now hang on to your socks. We're going to work our way through this, and if all these fractions bug you, then just hang on to the end. We're working our way toward a shortcut, and I'm going to show you the shortcut after we get through these fractions. So we're trying to find out how much will the bar stretch. What is it we are trying to find? We're trying to find deformation, aren't we? That's how much it stretches. What do we know? P, we know the 10,000 pound weight. Length, we know the 24-inch length. Area, we know the 1-inch area. E, we know the 30 million psi modulus of elasticity. So we know those 4 things, and we're trying to find out how much the thing will stretch. And this is a common thing that you would have. You know how big your weight is and how long and what size your bar is, and you know what the material is, and you're trying to figure out how much will it stretch. So that's what we're doing. We're looking for deformation. Okay, so what equation do we have with deformation in it? Strain is deformation over length. So rearranging the terms, we got deformation is strain times length. That's great, but we don't know what the strain is. We're looking for deformation. All we know is length, so we've got to figure out strain. What other equation do we know that has strain in it? Modulus of elasticity, stress over strain, stress over strain. So we could use this one, modulus of elasticity, to find strain. And then we could plug that into this strain deformation thing. But, and let's rearrange these terms. We'll switch places, the one by itself and the one on the bottom, because we're looking for strain. So now we'll have strain rearranged. Strain is stress over E. Okay, but we don't know stress. We're looking for strain. We know E. We don't know stress, so we've got to find stress. So we need another equation. Our good old stress is force over area. Do we know force? Yes, 10,000. Do we know area? Yes, 1 square inches. So we could work our way backwards from here. So we are going to need these equations, stress, modulus of elasticity, strain, in order to get back to deformation. So working our way back through them, first we find the stress. Then we plug that into our modulus of elasticity thing and rearrange the terms so we can find strain. Then we plug that into our deformation equation and use that to find deformation. So that was a big old long way around. Here's the shortcut. Here are these 3 formulas we were fooling around with that you know. Well, if E, modulus of elasticity, is stress over strain, and stress is force over area, you could substitute force over area in this fraction in place of stress. That's what I did there. And you know that strain is deformation over length, so in this formula, stress over strain, you could substitute this deformation over length in place of strain. Whew. So now we've got, if you do your thing with boiling down these fractions, now you've got P times L over A times deformation. That all equals E. That's what you come out with. E equals those four things. But if you're looking for deformation, remember our trick where we can switch the thing by itself and the thing on the bottom? We can do that here. We'll just switch the E and the deformation, and we come out with deformation equals PL over AE. And I like to call this PLAE. Deformation equals PLAE. That's our shortcut, and you can use that anytime you are looking for how much did something stretch and you have these four things, you're in business.